A data packet that was never meant to leave a secured NASA server started circulating through a small group of researchers late last night, and the moment they opened it, the room fell silent. The new trajectory file for 3I Atlas, timestamped only 6 hours earlier, showed a motion change that none of the teams involved had predicted or even considered likely. It was subtle, only a fraction of a percent, but it pushed the object several hundred kilometers off the modeled path. For an interstellar body moving at tens of kilometers per second, a shift like that should have been impossible without a clear physical cause.
Professor Loeb says that based on his calculations, it looks like 3I Atlas has been losing an extreme amount of mass.
Yet the file offered no visible explanation. There was no dust emission, no jet, no thermal spike, and no mechanical stress. Just the motion itself, quietly recorded and flagged as an anomalous event. The data came from NASA's Deep Space Network Station in Goldstone, where a routine tracking sweep had caught a faint but consistent deviation. The radar echo was weak, barely above the noise floor, but the pattern was stable enough that the software had marked it automatically. When a second pass 90 minutes later returned the same result, the anomaly was confirmed. Normally, a finding at that scale would be passed around internal teams for peer checks, but this time the file was attached to a restricted thread, followed by only a dozen senior analysts. That restricted thread is what ended up being leaked. No one is entirely sure who handed it off, but the metadata confirmed it originated inside NASA's own early review network. The numbers alone were enough to raise eyebrows. The drift was measured at roughly 0.007 degrees over a 6-hour window, which, when projected along the object's interstellar velocity, translated into a lateral displacement of several hundred kilometers. To put that into perspective, it is like watching a train move in a perfectly straight line for days and suddenly noticing it has shifted sideways by the width of a city block, without any engine movement or track change. 3I Atlas had already been unusual due to its non-gravitational acceleration, but this new shift took it into territory that even the more cautious researchers had not anticipated. What unsettled the analysts most was not the deviation itself, but the absence of any physical trigger. Normally, an object drifting from its predicted path would show at least one measurable signature: a faint dust plume, a gas jet, a temperature rise, or even a rotational change. But the leak included the infrared log, the photometric data, and a short magnetic field summary, and none of them showed anything. The body remained dark, cold, silent, and steady. No spikes, no dips, no pulses. NASA's modeling team had always kept a margin for uncertainty, but this event fell outside every known category of natural variation. Only a few hours after the leak started circulating, Chinese researchers monitoring the same object through their Mars-based Tianwen platform noticed they were no longer receiving the expected alignment confirmations. Normally, the system would issue tiny corrections based on the incoming tracking data, but those cycles began failing. By the time the engineers checked the logs, the platform had already over-allocated computing time to recapture the target. This may sound procedural, but in mission control, it triggered one of their internal alert levels. It meant the spacecraft's position predictions were diverging faster than the onboard system could compensate for, which only happens in cases of sudden object behavior changes. China had been watching 3I Atlas closely ever since the object's non-standard acceleration was identified earlier this year. Their interest was not political, but scientific. They had added a new set of observation windows specifically to support their deep space research division. When the updates stopped matching the expected path, the team escalated the issue. Although China has not released any public statement, 2 internal memos leaked through academic contacts stated that the behavior may indicate controlled or quasi-controlled dynamics. That wording alone caused immediate concern. It was far stronger than anything NASA has publicly acknowledged.
So is it a cosmic coincidence, or is it the first whisper from something that is not from this world?
The situation grew even more complicated when the leak revealed a second surprising detail. NASA had captured a short-duration radio fluctuation at a frequency that did not match any known solar, galactic, or spacecraft signal sources. It lasted only a few seconds, and it was extremely faint, but the timing lined up almost exactly with the trajectory shift. The analysts were quick to note that the detection came from a single station and could be a coincidence, yet the alignment in timing was impossible to ignore.
For nearly 11 minutes, radio receivers recorded a consistent, measurable signal, not random, not noise repeating at precise intervals. The signal's origin appears to coincide exactly with the path of 3I Atlas, which is now leaving the inner solar system.
It appeared in the raw file under an automatic tag, reading unclassified broadband anomaly. To understand the significance, it helps to imagine what would normally be expected. A natural body drifting through the solar system should only respond to gravity, radiation pressure, or small outgassing events. If none of those are present, the path should be stable. For 3I Atlas, the photometric records showed no brightness change greater than 0.01 magnitudes. The thermal logs showed no infrared spike, and the object's color, measured in standard visible band spectra, stayed almost perfectly flat. There was no sign of dust release, gas escape, or any of the usual effects that could push a body off course. In fact, the flatness of the thermal profile puzzled the team even before the leak. It was cooler than expected, almost as if it lacked a surface layer that absorbs and re-emits sunlight. The leaked thread showed NASA's researchers attempting to reconcile the numbers with every known physical mechanism. They checked for a microfragmentation event, but the brightness would have changed. They considered a small impact with a pebble-sized particle, but the motion change was too clean. They tested for thermal recoil, but the temperature was too stable. And they reviewed the object's rotation model again, but the drift did not match any torque-driven shift. By the end of the discussion, the provisional conclusion was that the object's behavior matched no known natural model. This is where China's concern becomes clearer. According to the internal memo, Tianwen's navigation system logged the drift in a way that mirrored a maneuver. Not a deliberate propulsion burn, but the kind of consistent lateral shift seen in controlled spacecraft when they make fine adjustments over time. It was small, refined, and smooth. There was no oscillation, no wobble, no signature of random motion. Chinese analysts described it as resembling an artificial correction pattern, though they avoided directly calling it intentional. The wording they used instead, quasi-controlled, reflected the uncertainty. It meant something that behaved like a controlled system without necessarily being one. The memo also revealed that Tianwen captured a brief optical flicker on the object's silhouette, lasting just under 1/10 of a second. It was far too short to draw conclusions from, but the timing, again, overlapped the trajectory shift. Engineers suggested it might be a reflective surface passing through the camera frame at a particular angle, though the shape of the object in earlier images had appeared rough and irregular. If a flat panel existed, it would change everything researchers thought they understood about the structure. As the hours passed, the scientific community shifted from confusion to urgency. If the trajectory deviation held, it meant every prediction for the next several weeks was now too uncertain to rely on. And because the object was still inbound toward the inner solar system, even a small change could place it near observational assets that were not prepared for unplanned encounters. NASA had previously projected a distant pass near the orbit of Mars, but the new data widened the uncertainty band dramatically. It was not a matter of danger, but of planning. Telescopes needed lead time, tracking stations required updated schedules, and spacecraft teams had to decide whether to allocate additional resources. The leaked thread also showed that NASA's propulsion modeling group ran a simulation using the Aoni non-gravitational parameter set at roughly 0.2 times 10 to the minus 8 astronomical units per day squared, plus or minus 0.05, to see whether it could account for the drift. But the motion change did not line up. The direction was off by several degrees, and the timing did not match the expected energy profile. Something else was acting on the object. What made the situation even more pressing was the final note added to the file. One of the senior analysts wrote that if the shift continued at the current rate, the object's projected path would intersect a region of high observational interest within 2 days. This region was where several spacecraft communications relays aligned during scheduled cycles. The concern was not collision, but interference. The radio fluctuation recorded earlier raised the possibility that the object might produce its own broadband noise under certain conditions, and mission planners did not want their signals disrupted. China's anxiety likely comes from the same uncertainty. Their deep space operations rely heavily on precise alignment windows. If 3i Atlas continues behaving unpredictably, it could complicate their ability to gather consistent observations. And because they have invested significant national effort in tracking the object, any loss of data could set back months of research. As the leaked information spread quietly among astronomers, the debate shifted from whether the object was natural to whether the behavior could still be explained without invoking artificial mechanisms. Many scientists remain cautious, pointing out that interstellar bodies can carry unknown materials or structures that behave in unexpected ways. But others note that every major anomaly so far has lined up in ways that are statistically uncomfortable. The non-gravitational acceleration, the stable cold temperature, the lack of outgassing, the unusual rotation pattern, the ultra-low albedo surface, the radio fluctuation, and now the coordinated trajectory shift. Each one could be natural, but together they form a pattern that is hard to ignore. In the leak discussion, one researcher summed up the puzzle by saying, "It felt like watching a lighthouse beam sweeping across the ocean, while insisting it must be a random splash of light from the waves." The analogy, while informal, captured the sentiment building behind the scenes. No one wants to jump to conclusions, but no one can explain the data either. For now, all teams can do is wait for the next tracking sweep. If the drift continues, it will confirm that this was not a one-off event. If it stops, it may point to an internal mechanism inside the object that activated briefly. Either scenario is unprecedented. The truth is that researchers across the world are facing a moment they rarely encounter, a situation where the evidence does not match any known category, yet the implications of admitting that gap are enormous. It is a reminder that even in an age of advanced observatories and deep space networks, the universe still finds ways to surprise us. And until NASA or China release an official explanation, the mystery surrounding 3i Atlas will only grow heavier. What is certain is that the next observation window will be the most important one yet. A single confirmation could reshape months of assumptions. A single contradiction could unravel the remaining models. And the world will be watching closely as scientists search for answers in the silence of deep space, hoping the numbers finally begin to make sense.